This is Eddie Hebert from Southeastern Louisiana University. This is a series of lectures for motor learning class. And in this lecture series, we're talking about proprioception. So we have a lab for our class. We'll either do it in class or I might have you do it at home. There are two activities in the lab. One of them is to balance with your eyes open and then balance with your eyes closed and measure how well you can balance under both of those conditions. The second activity is where we are trying to measure our sense of arm positioning. Sometimes this is called joint position sense, where with a partner you'll work with they'll close your eyes and they'll move your hand to put it on a table somewhere and then return it back to your side, and then still with your eyes closed you're going to try to reach out and put your hand on the table exactly where you were, and we'll measure how close you are to that spot. Both of these activities measure something about our sense of proprioception. So over the course of the semester, we have learned or practiced, or we will learn or practice a lot of different motor skills. And all motor actions require us to coordinate our bodies. And we use that term coordination pretty loosely. And so coordination is where you have to produce a smooth pattern of motion. And you do this by contracting certain muscles, not contracting others, and then also contracting those muscles at the right time and with the appropriate intensity. And so I have three pictures here of people who are performing some actions. One is a person who is standing on a Bosu ball, an unstable surface, and trying to balance on one leg. And this is a difficult task that requires that you coordinate a bunch of different body parts. I have another person shooting a basketball. And to shoot a basketball, you have to produce the shooting action, and you have to do it in such a way that you provide the right height and force on the ball so that it travels the right distance and lands in the basket. The third example here is an everyday activity where we might be carrying a number of objects. And so as the number of objects and their weight and size and shape change, it requires a different movement on our part. And we have to, again, coordinate a bunch of different body parts. And so the body's sense of proprioception, what is that? Normally, whenever you think of proprioception, we understand that it's an understanding or an awareness of where our body parts are in space. If you close your eyes and put your arms out to the side, and I ask you to touch your nose with one of your fingers, you likely can. You can find your nose with your finger. And this requires that you understand where your body is in three-dimensional space. The definition of proprioception is the body's ability to transmit and interpret information from sensory receptors located in your body. So we have receptors located throughout our body that send signals to our brain, and our brain has to deduce or figure out what are all these signals telling us about our motion. And then we have to utilize that information to respond appropriately, right? So if we're standing on a Bosu ball and we begin to lose our balance, we have some different sensory receptors that are telling us about our sense of balance, and then we have to adjust our arms or our legs so that we can maintain our balance. So we have to gather information from our sensory receptors and then make sense of it and then physically act. Now the sense of proprioception, we could measure different aspects of it, and it includes at least three different parts, three different aspects of proprioception. One of them is an understanding or a perception of our location of our body parts and our movement of them. Sometimes this is called joint position sense. We also have to be able to adjust forces. So if I'm carrying a coffee cup in one hand and a bunch of groceries in the other, I have to produce the right amount of force so that I don't crush the cup or also drop it. And I have to produce the right amount of forces so that I can hold all those objects. The sense of proprioception also includes our sense of balance and our ability to maintain it. Now, we measure proprioception in a lot of different settings, and here are just some examples. There's a person who's standing on the side of the road at night with a policeman who's doing a field test of sobriety. And in this activity, the person is closing their eyes, tilting their head back, putting their arms out, and then touching their nose with one hand and then the other. So this is measuring our sense of proprioception. Baseline measures of concussion also include tests of balance, where you might have to stand on an unstable surface, and we'll see if you can maintain your balance or if you lose your balance and how often you do so. So this is a measure of your proprioceptions that might be influenced by getting a knock in the head. Then finally, you might go to a physician, and during a regular physical exam or maybe a neurological assessment, they're going to do various tests of some of the proprioceptors in your body. Now, we understand that this sense of proprioception, our awareness of our body in space, our perception of forces, and our ability to maintain our balance, we believe that that sense underlies movement, and it's likely related to us being able to move in a skillful way. To be able to shoot a basketball with the right amount of force requires that I understand the positions of my body, and I'm also be able to adjust forces appropriately, and this is part of our sense of proprioception. We also believe that proprioception improves with practice. The more you use your body or perform a certain action, the better our sense of proprioception develops. We also believe that people who have better proprioception are better movers, maybe better athletes. To be able to do gymnastics, I really have to have an advanced sense of proprioception to be able to do all of the tricks, all of the apparatus. I mean, to what extent has science really shown that proprioception is related to athletics or moving appropriately? There's an early study, 1995, where they basically got athletes and non-athletes, and they measured joint position sense in the knee. For example, do you realize how straight or bent your leg is? And they essentially found out that athletes had a better joint position sense. That suggests that either physical training improved their proprioception, or people who have better proprioception are just generally better in sports. So in this first part of the lecture, I'm going to share with you another research study that looked at the link between proprioception and athletics. So this is a study of proprioception and basketball shooting. I like this project because it uses a skill that I've done on a regular basis so I can understand it. And I can also understand how they measured proprioception. So the purpose of this study was to look to find out, is there a relationship between our joint position sense, JPS, and the elbow and wrist? Is that related to basketball shooting? What I mean is, are better basketball shooters better able to understand the positioning of their arm and wrist? So in this study, they got 21 college basketball players, both male and female, and they wanted to measure something about their shooting ability. So they had them shoot 50 regular free throws from the free throw line, just like they always do. And then they also gave them a novel or a unique basketball shooting task where they had them sit on a chair about halfway between the free throw line and the goal and shoot 50 shots from that seated position. So this is probably a shooting task that they might have never done before. It's a unique task, but it does measure something about their understanding of how hard to shoot the ball, how can they adapt their shooting to a unique shooting situation. So they basically measured how many free throws that they could make from the free throw line and also how many shots they made from this sitting position. Then they took these 21 basketball players and measured their joint position sense in their elbow and wrist. And so you can see the picture of the apparatus that they used. The athletes were blindfolded. They sat in this chair, and they had their arm connected to this device where the elbow could flex and extend, so they could straighten out their elbow and they could bend their elbow. This is kind of like this shooting motion or a pushing motion. And while they were blindfolded, the researcher would move their arm forward to a certain spot, pause, and then move the arm back to where it began. And then the player was asked to straighten your arm out to the spot where it just was, where you believe that location was. And they did this for several different locations. Can you find your arm position, your elbow position blindfolded? Can you replicate or repeat exactly where your arm was? And then they measured how accurate they were in positioning their arm. And then they did the exact same thing with the wrist. And so they set them up in this, this apparatus where the wrist joint could flex and straighten, bend and flex their wrist joint. And again, they positioned their hand or their wrist in a certain spot, moved it back to its original position, and then asked the athlete to place your hand or your wrist in the exact location where I had just had it. So blindfolded, can you find the position of your elbow and your wrist that we just had placed it in? And then they looked at the relationship between these two things. Was there a relationship between how accurately you could position your wrist and your elbow and how many baskets you made? And in fact, there was. There was a correlation between the number of free throws you made and your sense of joint position, or your joint position sense at the wrist and the elbow. Put simply, people who made more basketball shots had better joint position sense, and people who made fewer shots had worse joint position sense. So the conclusion was that the sense of proprioception, or joint position sense in the elbow and the wrist, was related to basketball shooting performance. Now, what the study didn't address was which of these is first, right? Chicken or the egg? Do people who shoot better do so because they have better joint position sense? Was joint position sense there, and therefore people can learn to shoot better? Or do people who tend to shoot more develop better joint position sense? So the study really said there's a link between these two, but we really don't know, did they develop at the same time, or is one first and then the other one comes second? The important thing was proprioception underlies movement and movement skill.